Right, good day, Matrix. I'm sure you're tired like me. It's tiring going into school and then it's all just a bit of a pain in the bum. Right, the last two lessons were a bit of a hash, so I'm afraid you're going to have to do some on your own at home. So we're going to do 6.11 on page 270, and we're going to do question C, and I'm going to go through C, E, and G with you. Okay, D and F you're going to do on your own. I'll send you a memo. As I said, these are very common section B questions. Okay, so you do need to get to grips with them. Okay, if you really want to smash things. Okay, let me just switch screens. Okay, right. So here's the question for 6.11, page 270. You've got a cube, a shoebox with no lid. Okay, and you're told the surface area is 200 centimeters squared. Okay, based on that information, go show that y, the height is y, the length is 3x, the breadth is 2x. Show that y is 20 over x minus 3x over 5. So if you couldn't do this, use that for the next question. Anytime they say to you, show something, they're asking the question like that instead of just saying, I don't know, some other form. So that if you can't get number one, you can at least do number two still. So your surface area, well, you've only got one of these things at the bottom because there's no lid. If there's a lid, you would have said two of those. So you've got one, the yellow thing at the bottom is 3x times 2x. And the area of a rectangle is length times breadth. So that's going to be 3x times 2x, which is going to be 6x squared. Plus, okay, you've got two of these ones on the side. And the dimensions of the one on the side are 2x over here. Okay, and you've got a height of y. So I've got 2 times 2x times y. 2 times 2x times y. So it's going to be plus 4xy. Okay, and then, so that's the two ones on the side, and then the two in the front, so this one at the front here, and the one parallel to that at the back, okay, the dimensions of those ones, okay, are going to be 3x over here, okay, 3x times y. So it's 2 times 3x times y. You can skip out steps, so that's going to be plus 6xy. But we know that the surface area, okay, is equal to 200. So you've got 200 is equal to 6x squared plus 4xy plus 6xy. So you get 200 is equal to 6x squared plus 10xy. But now we want to show that y is equal to something. So we want to get y on its own. So we're going to have 10xy is equal to 200 minus 6x squared. And to get y on its own, you're going to have to divide by 10x. So y is going to be 200 over 10x minus 6x squared over 10x. So y is going to be equal to 200 divided by 10 is 20. So it's 20 over x minus 3 over 5x. So we proved what we were asked to do, which is to show that y is 20 over x minus 3x over 5. Okay. Right, then it says go find your volume in terms of x. Now the volume is area of base, which of any prism is length times breadth times the distance between the base and the other parallel side. So volume is length times breadth times height. So volume is equal to, well, your length is fine, that's in terms of x. So volume is 3x, your length is 3x, your breadth is 2x, and your height is y. But we know that y is equal to, this is what I'm saying, if you couldn't work this out for this question, use it for the next one. So y is going to be equal to, so even if you didn't prove that, use that over here. 20 over x in an exam scenario, minus 3x over 5. So volume is going to be equal to 6x squared times 20 over x minus 3x over 5. So volume is going to be, well, 6 times 20 is 120. X squared and x leaves you with x squared over x, and this is going to be minus 18 x cubed, okay, over 5. Let me double check I got that right. Yep, I did. Volume is 120x minus 18 x cubed over 5. Okay, so now I've got a formula for the volume of this box. Question 3 says calculate dimensions. When they say find the dimensions, they mean what's the length, what's the breadth, what's the height. Okay? So calculate the dimensions of the box in order to maximize the volume. Well, we know that volume is equal to negative 18x cubed over 5 plus 120x, right? Which is, okay, right. So there's our volume over here. So it's a negative cubic, should have that kind of shape. Starts with a negative, ends with a negative. And we want to maximize the volume. So now when we're trying to maximize something, we want to know that where the gradient is equal to 0. So we want to know where dv dx, remember the maximum always happens when the gradient is equal to 0. So we want to know maximum and minimums happen when the gradient are 0. So we want to know where dv dx is equal to 0. So I'm going to have to differentiate this. And 18 times 3 is 30, 8 3 is 24, 54. So it's going to be negative 54x squared over 5 plus 120. And we want to know where that's the gradient. And we want to know where the gradient is equal to 0. So we're going to solve for x. So you're going to have minus 54x squared over 5 is equal to negative 120. So you're going to go x squared is going to be equal to, well, the negatives are going to cancel, and you're going to be left with 120 times 5 divided by 54. So you get x squared is equal to 100 over 9. So x could be plus or minus the square root of 100 over 9, but x can't be negative, so it's just the positive version we're looking for. And the square root of 100 over 9, well, the square root of 100 is 10, the square root of 9 is 3. So the maximum volume will occur when x is equal to 10 over 3. Yep, I'm indeed correct. But the question said go find the dimensions. So if you go back here, your length is 3 times x. So your length is equal to 3x, which is going to be 3 times 10 over 3, which is equal to 10 centimeters. I think it was in centimeters. Yep. So length is 10 centimeters. Okay, so we've got the length is 10 centimeters. Then we're going to have the breadth, and the breadth is equal to 2x, which is 2 times 10 over 3, which is equal to 20 over 3 centimeters. You can round it off if you want. And then we're going to have the height, and the height is y, but we know that y is equal to 20 over x minus 3x over 5. So it's going to be 20 over x, so it's 20 divided by x is, what is x equal to 10 over 3? So 20 divided by 10 over 3 minus 3 over 5 times by 10 over 3. And if you shove that into your calculator, you should get an answer of 4 centimeters. Okay. If they had said to you what is the maximum volume itself, okay, not what, so that answers the question that they asked, what are the dimensions, length, breadth, and height. But if they said to you what's the maximum volume, which they didn't ask, but I'm just going to show you because it's a common question. Well, we know the maximum volume happens when x is equal to 10 over 3. So the volume would be 120 times 10 over 3 minus 18 over 5 times 10 over 3 all cubed. You'd shove that into your calculator, okay, and that'll be your formula for the maximum volume. Fantastic stuff. Right, that is question. I'll send you a photo of my answers as well. Okay, that's the end of question C. Okay, right. Then I'm going to skip D. You can try that by yourself, and let's have a look at E. And E says, okay, a solid cylinder is cast from 10 liters of molten metal. The cylinder is then covered by a layer of rust-proof paint. Calculate the radius and the height of the cylinder in centimeters such that the minimum quantity of paint is to be used. So you've got a solid cylinder, you're painting the darn thing, okay, and you want the volume to be a liter. Now, I don't think you expected to know this, but you kind of should. Okay, 1 liter is 1,000 centimeters cubed. Okay, so the volume they're telling us, okay, is 10 liters. So the volume of the cylinder is 10 times 1,000, which is 10,000 centimeters cubed. Okay, right. Let's double check that. Okay, right. Now, we want to know, we're told that this is the radius, okay, and we've got my height over here. That's your height between the two parallel sides. And the question said, so we've got the volume, calculate the radius and the height such that the minimum quantity of paint must be used, not to minimize the amount of paint. You're not minimizing volume. Okay. If it was full of paint, you'd be minimizing volume, but they want to paint the outside. So you're minimizing the surface area. So whatever you're trying to maximize or minimize, you've got to get a formula for that in terms of one variable only. So what's the surface area going to be? Okay, it's a solid cylinder, so there's a top and the bottom, right? So this, for the surface area, I've got two circles with radius r. Okay? Plus, okay, well, if I unravel this, okay, if I take a piece of paper, I don't know if you can see anything, and I unfold it, what this is going to be here is the height, and what this is going to be here is the circumference. So if I took a cylinder, okay, unfold it, this is my height, this is my circumference, and my circumference is equal to 2 pi r. So I've got the one dimension of the rectangle is height. This is the sides of a, here, I've got a cylinder, unfold it, circumference, there's your circumference, there's your height. So I've got a rectangle as well, surface area is the amount of outside of the substance, okay, where this is my length, which is 2 pi r, and this is my height here, which is h. So your surface area, okay, is made up of those, okay, the top and the bottom, and then the side of the cylinder, which ends up being a rectangle, because this over here is my circumference. Okay, right, once it's unfolded. So your surface area is going to be, area of a circle is pi r squared, so it's going to be 2, because I've got a top and the bottom, so it's 2 pi r squared, and then I've got a rectangle here, so that's the 2 pi r squared, and in the rectangle the dimensions are 2 pi r and h, okay, and the area of a rectangle is length times breadth, so it's plus 2 pi r h. So that's the formula for surface area, but there's a problem, because we're going to have to minimize surface area, okay, and to minimize surface area, I'm going to have to differentiate. And you cannot, at this stage of your life, differentiate in terms of two variables. If you carry on with velocity mass, you'll be able to. So what I'm going to have to do is I'm going to have to get rid of this h. Okay. So I'm going to have to express h in terms of r. And they must give me some other information which will allow me to do that. And they do. They tell me that the volume is equal to 10,000 centimeters cubed. And the volume of a cylinder is the area of a base, which is a circle. So the area of a circle is pi r squared. That's the area of your base, times the distance between the two bases, okay, which is h. So pi r squared h must be equal to 10,000. We want to get rid of h. We want to express it in terms of r. Always leave it in pi form. So h is going to be equal to 10,000 over pi r squared. So this enables me, why did I want to do that? Because I've got to express surface area in terms of one dimension, okay, in terms of just r. So now if I sub 1 into 2, what I'm going to do is replace every h with 10,000 over pi r squared. So my surface area is going to be 2 pi r squared plus 2 pi r. I replace h with 10,000 over pi r squared. Okay, so I end up, if I simplify that, my surface area is 2 pi r squared. Here the pi's will cancel. Okay, 10,000 times 2 will be 20,000. Okay, and r squared will leave me with 1 r at the bottom. So I get a formula for surface area in terms of one variable only. Okay, and my surface area should be 2 pi r squared plus, plus 20,000, okay, over r. Okay. Now they say, okay, right, you've got your surface. Now part 1 is achieved. I've got a formula expression for surface area in terms of one variable. You could have got it in terms of h, it would have been more of a mission. Now the question says, go maximize the surface area. Okay. So to maximize the surface area, okay, we want to know where the gradient is equal to. Remember, maximums occur when the gradient is 0. So you can start them always with, when is the gradient going to be 0? Well, when the derivative, well, ds the derivative of surface area in terms of the radius is equal to 0. So to do that, we first have to get the variable in the numerator. So surface area is 2 pi r squared plus 2000 r to the negative 1. Okay. I just move the power of r up and I change the sign of the exponent. So the derivative must be equal to 0, and the derivative of 2 pi r squared is 4 pi r. Pi is a constant, remember, minus 2000, okay, minus 2000 r to the negative 2, and we want to know where that's equal to 0. So if I solve that, I get 4 pi r is equal to 2000, okay, move that across, over r squared, okay. If I go here, I'm going to get 4 times both sides by r squared. Remember, r cannot be 0. You don't lose a solution if you times by a variable. Okay, you just got to write your restriction, but you do lose a solution if you divide by a variable. So you get 4 pi r cubed is equal to 2000. Okay, divide by 4 pi, and you're going to get r cubed is equal to, well, 2000 divided by 4 is 500. So r cubed is going to be 500. I'm dividing both sides by 4 pi. So you're going to get 500 over pi. So r cubed is equal to 500 over pi, 5,000. Sorry, this was 20,000. 20,000. 20,000, right? So it's going to be, r cubed is going to be 5,000 over pi. So r is going to be equal to the cube root. We don't have to worry about the plus minus for cubes of 5,000 over pi. So r is cube root of 5,000 over pi. And to 2 decimal places, you're going to go shift cube root of 5,000 over pi equals, and you get 11,68. So the radius, in order to maximize the surface area, must be 11,68 centimeters. So there's your radius. And to find my height, well, I know that my height over here is equal to 10,000 over pi r squared, and the maximum is going to occur when r is equal to 11,68. Keep it on your screen, we'll just use the answer button. So your height is going to be equal to 10,000 over pi. What's radius? It's 11,68 dot dot. Okay, just use your answer button in your calculator, all squared. So if I enter that and go 10,000 over shift pi times answer squared, you should get a height of 23,35 centimeters. So there is your height. Yep, correct. Okay, so the question was, okay, go find, calculate the radius and the height. We've done that. Okay, if I said to you, what is the surface area? Well, we would simply have plugged r back into this formula over there, and it would give us the minimum possible surface area. So what are my steps? So I have to minimize surface area. How did I start? Okay, I said, okay, just get a formula for surface area. But I had it, once you see that it's in terms of 2 variables, they must give you some other information to enable you to eliminate the that variable. They did, they told us about volume. That enables us to eliminate h, sub that in, okay, and kapish, kaposh, I'm done. Right, last one, G. Now, for any other shape that isn't, for any shape that isn't a prism, in other words, that's got 2 parallel sides joined by a rectangle, they're supposed to give you a formula for what the volume is. And the volume for a right cone, okay, the formula is 1/3 pi r squared times h, where h is your perpendicular height of the cone going through the center of the cone. So, and this is my radius. The r stands for the radius of the top formula. AP students, you'll do the proof of this by integration. So the first question says that's h and that's r, and they say to you the sum of the height and the height and base radius is 12 centimeters. So they say to you the height plus the radius is equal to 12. So to express r in terms of h, r is going to be equal to 12 minus h. So my radius I can write as 12 minus h. Okay, because I said to you in the question, the diagram is a right circular cone of height 8 centimeters and the base radius r. The height is the sum of the base and the radius is 12 centimeters. So that's quite simple over there. Let's call that equation 1. Now it says find volume in terms of h. So we know that volume is equal to a third pi r squared h. Okay, but we know that r is equal to 12 minus h. So if I sub 1 into 2, okay, I'm going to get volume is equal to a third pi, r is 12 minus h squared. I've just replaced r with 12 minus h, okay, times by h, right? So I get volume is equal to a third pi h times 12 minus h squared is going to be equal to 12 squared, it is 144, times them together times by 2, minus 24h plus h squared, that's that all squared out, 144 minus 24h plus h squared, third pi, yep, okay, and if I times that in, I get a third pi h into that equation. Well, 144 divided by 3 is 48, okay, so volume is going to be equal to 48, okay, 48 pi k h. So your volume is 48 pi h. Okay, 24 divided by 3 is, so I get 48 pi h minus 8 pi h squared. Okay, if I times that out, you're going to get 24 divided by 3 is 8 pi h squared. Okay, plus pi h cubed. Okay, over 3. Okay, so I get volume is equal to 48 pi, let me just check I've got this right, minus 8 pi h squared, good, plus pi h cubed over 3. Voila. Okay, so there is your volume. Okay, 48 pi, okay, minus 8 pi h squared plus pi h cubed over 3. Okay, right, okay, then the last one says, hence go find the maximum volume of the cone. So the maximum volume, remember, if you've got a cubic, this by the way is a positive cubic, and you can actually use this. Remember that if you've got a cubic function, okay, that starts with a positive and ends with that, where the coefficient of x cubed is positive, which it is in this case, it's going to be start with a positive gradient and end with a positive gradient, which means that your first value is going to be your maximum. Okay, so the maximum volume is going to occur when dv dx is equal to 0, when your gradient is 0. So dv dh, sorry, when dv dh is equal to 0, so the derivative of 48 pi h is just the coefficient of h, which is 48 pi. Okay, the derivative of this in terms of h is going to be minus 16 pi h, and the derivative of this, well, it's going to be 3 over 3, which is going to cancel, so it's going to be plus pi h squared, and I want to know where that's equal to 0. Okay, so now you've got a quadratic. You've got pi h squared minus 16 pi h plus 48 pi, and you want to know where that's equal to 0. So go use your calculator. Okay, I'm just double checking I'm correct. Well, actually, I'm being a complete dumbass. That's equal to 0, so let's divide minus 16 pi h, sorry. If I divide everything by pi, I'm going to get h squared minus 16h plus 48 is equal to 0. Okay, right, and that actually can factorize. 48, 12, and 4 will be h minus 12, h minus 4 is equal to 0. So you get h is equal to 12 or h is equal to 4. The question is, which gives you the maximum volume? Okay, the question was go and minimize the quantity of paint, determine the maximum volume of the cone. So the maximum volume of the cone, well, we had a cubic. Okay, so the maximum is going to come first and then the minimum. So the maximum should be at h is equal to 4. Okay, right? Does that make sense? It's worth knowing these shapes. I'll go over that again. You've got a cubic function here. Okay, this links to that. The coefficient of h cubed is pi over 3, which is positive. Okay, if you've got two stationary points in core, if you remember the graphs, if you've got two stationary points and the coefficient of the cubic part of the equation is positive, it's going to be start with a positive, end with a positive. So the maximum then would be the first. The minimum will be the second. So the maximum is going to be at h is equal to 4. The other way you could test it is you could go back and you could put h is equal to 4 into this equation and work out your volume, and put h is equal to 12 into this equation and get your volume. I wouldn't do that. I would use this though. Okay. So remember, if you've got volume is equal to a positive exponent, x cubed plus blah, 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 some cubic question, anything. So if you've got y is equal to something, something, positive exponent x cubed, the shape of the graph will be like that if you have two stationary points, which tells you get your maximum, then your minimum. If you had y is equal to, and you can always get that to be positive because it's equal to naught. Okay, but if you had y is equal to a negative x cubed, it would start with a negative and end with a negative, which means that this would be my minimum, and that would be your maximum. Okay, right. So the maximum occurs when h is equal to 4. The question then said, what is the maximum volume of the cone? Well, the volume, you're going to replace, go back to this equation over here. Okay, actually the easiest would be to go back to here and replace h with 4. So volume is going to be a third pi 12 minus 4 squared times h, which is 4 again. So volume is going to be a third, okay, pi, 12 minus 4 is 8, 8 squared is 64, 64 times 4 is 256, okay, so that's 256, okay, times 256, and if you enter that into your calculator, so you could write it as 256 pi over 3, but as I said to you, get that to a certain number of decimal places, okay, then your volume would be equal to 256 pi over 3, which is equal to 268,08 centimeters cubed. Okay, right. Quite a nice sum. All right, guys. Thanks for that. Okay, have a good one.